Okay. Based on the past records, the main printer in the computer center of a university operates properly 90% of the time. If the main printer is inspected 10 times randomly, so that means that we are going to check a computer 10 times. And every time we check the computer, it could be operates properly or not operating properly. Of course, we want it to be operating properly, so the probability is 90%, which means 0.9. This is probability of success. Okay? Therefore, we could now define the random variable. Let's do it here. Number 12. Let x be, so what should I do with the wordings? Let x be what? Let x be the number of times it operates properly. The number of times it operates properly among 10 times. Okay? Then we know that x follows a binomial distribution with, we are going to check 10 times. So we have to put 10 here. And for each of the time, the result could be either operating properly or not operating properly. Of course, we want it to be operating properly. So what is this probability? 0.9. 90% means 0.9. Okay? Yes. Then let's look at part A1. Let's look at part A1. Find the probability that the main printer operates properly in exactly X inspection. So what does it mean? We have to find, so among all these 10 times inspection, we want 8 of it operating properly. 8 times success out of 10 times. We need x equals to 8. X equal to 8. This is part 1, what we are looking for. And then part 2, at least 8 inspection operates properly. At least 8. What does it mean? It means more than or equal to 8. So that it means that you have to find not only x equal to 8, but also you have to find x equal to 9 and also x equal to 10. Right? So you are going to use the formula 15C8, 0.9, 0.1, 8, and 2. You have to use the formula 3 times. Okay? This one also you have to use the formula. Oh no, 15. How come 15? 10 times only. 10. 10C8, 0.98, 0.12, right? Okay. And then, whoa, what about this? At most, 8 inspection. What is that? At most. At most means that it could be equal to or less than 8. At most, 8. So that means what? That means x could be equal to 0, 1, 2, 3, 4, 5, 7, 8. It's going to be very long. Any other options do we have? You may also use 1 minus x equal to 9 minus x equal to 10 is faster because you do not need to use the formula so many times, okay? So, and then, what about next? What is the expected number of times the main printer operating properly? Oh, you understand this word? Expected number means what? Means we have to find expected value of x, right? Expected value of x, expected number. So we know that it is just 10 times 0.9. 10 times 0.9, which is 9. So this is the expected number. Okay? And then let's look at number 13. Or you may now push the pause button and then you may try to figure it out by yourself. Okay? Now, let's do it. Number 13. Among 16 participants of a game, there are totally 16 people, 12 of them having a university degree. A participant is randomly chosen from these 16 people each time to answer a question, where the probability of choosing any participant each time is equal. If 3 questions has already been answered, so that means that 3 people has already been chosen, right? Find the probabilities of the following events happening. First of all, no participant with a university degree is chosen. So what are we doing? Think carefully. What are we doing? We are going to choose a people out of these 16 people, right? We are going to choose a people out of these 16 people. And how many times have we choose? We choose 3 times because 3 questions has already been answered. So we are going to do this, choosing people 3 times. Therefore, let x be, what should be x? Let x be because we are looking for a people with a degree. So you should let x be the number of people with a degree. Let x be the number of people with a degree chosen out of or among 16 people. No, out of 16 people? No, not 16 people. Let x be the number of people with a degree chosen among 3 times 3 Charles. Do you agree? Now we are talking about the 3 questions which has been already answered. These 3 questions, and these 3 questions are answered by 3 people. Okay, and we are looking for the number of people among these 3 people with a degree. so that you should let x be the number of people with a degree. Or I should say it more clearly. Let x be the number of people with a degree among 3 people. Let x be the number of people with a degree among these 3 people. Then x follows a binomial distribution. So there are 3 people, we have to check one by one, and for each of them having a degree, with a degree, what is that probability? Do we know this probability? The number of people with a degree? What is the probability of the people with a degree? Among 16 people of the game, 12 of them have a degree. So the probability for having a degree should be 12 over 16. This is the probability of having a degree among this group of people. 12 over 16. Wait, 12 over 16. 12 over 16 is 0.75. 0.75. Okay. So we have already defined the random variable, and also we can tell what kind of distribution that it follows. And then part A, what are we looking for? Find no participants with a university degree is chosen. Among these 3 people, no one with a degree. So we have to find the probability of x equal to 0. Okay? And then you use the formula. C3C0, probability of success means with a degree, we need 0 of them. The probability of failure, no degree, we want 3 of them. Okay? And then 1 participant with a university degree is chosen. So 1 participant, we need x equal to 1. What about number C? 2 participants with a university degree each are chosen. So 2 participants means you have to find x equal to 2. And then D, given that, look at this. Given that at least 1 participant with a university degree is chosen, all participants chosen have a university degree each. Oh, look at this carefully. Can you see here? Given that, do you remember given that? Let's write here. Oh. Given that, part D. Probability, given that, right? Given that what? At least 1 participant with a degree. So we need x at least 1 means bigger than or equal to 1. Given that at least 1 participant with a degree. All participants chosen have a university degree each. We have to find the probability that all participants have a degree. So x equal to 3. We have to find the probability that given that at least 1 of them has a degree, we have to find the probability of all of them have a degree. So this is the situation. Remember how to deal with this. How do we call this? Conditional probability. So according to the conditional probability rule, it becomes probability of x equal to 3 at the same time, x bigger than or equal to 1, divided by x is bigger than or equal to 1. Okay? We need x equal to 3 at the same time, we need x bigger than or equal to 1. So what is the intersection happening at the same time? What could it be? X could be only equal to 3. So x equal to 3 on top. And then x is bigger than or equal to 1 as the denominator. You have to split it up into 1, 2, and also 3. Okay, and then you continue. Is it more clear now? Okay, so, and then after that, we have to look at also a very classic question. Let's go back to the example. No, before the example, let's look at this. This one. Look at our own examples. So, please look at 1A. In a game, Logan tossed a coin 10 times. Getting 10 heads means win. What is the probability that Logan wins? So, toss a coin, right? Toss a coin, getting a head. The probability is 0.5. Assume that it is a fair coin. And then Logan is going to do this silly thing 10 times. So this is a binomial distribution. We should let x be the number of heads obtained amount, how many times? 10 times. Amount 10, or you may say trials, 10 times, 10 trials. Let x be the number of heads obtained among 10 trials. And then x follows binomial distribution. Totally, there are 10 trials, 10 times. For each of the time, this is 10. And number of heads obtained. The probability of success is the head obtained is 0.5. Okay, it's very clear now. We know what is x, what does it mean by x, and what is x. And now what are we looking for? Find what is the probability that Logan wins. Wins means what? Getting 10 heads. In all these 10 times, we need to get 10 heads, so very demanding. We need to find the probability of x equals to 10. Okay? So of course you could use the formula 10C10, the probability of success. We need 10 success, means failure 0 time. Okay? Dot, 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 dot. Oh no, we also need to find that. So, what do I need to find? 0.5. So very windy here in this classroom. 0.5 to the power of 10, and then times, to the power 0 means that it becomes 1, you need 10 C's, 10. Okay, do you see that, what we've got here? 9.765625 times 10 to the power of negative 0.4, so that we are going to move the decimal point. But if you hate to do that, you could use this method, plus 1. I'm going to plus 1. So it becomes this. So the 1 is just what I just made it up, so you should ignore it. There's no 1 here, so that means that the number should be 0.000976563. Okay? And then you're supposed to give your answer in 4dp, so that in 4dp your answer should be 0.0010. This is correct to 4dp. Okay. So remember, you have to copy this down from calculator first, and then after that correct to the required accuracy. Because later, if you have to use this probability, you should not use this one. This one is not accurate enough. You have to use this one. All right, so part B, Logan is going to play this game. So in this game, Logan tossed a coin 10 times. And only if you can get 10 heads, that means that you win. Remember that? And then Logan is going to play this game every day through a week. So every day he's going to play one time, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Play one time every day, and then for a week. What is the probability that Logan wins 5 times? So, we should let a new random variable. Let y be the number of times he wins the game. Okay? We are looking for number of times that he wins the game. How many times totally are there? Through a week. So every day he play one time through a week. That means 7 times. 7 trials. Okay? So that at least y should be equal to 0 or at most y equal to 7. He totally plays 7 times only. And then y follows a binomial distribution. So totally, he repeat this silly thing 7 times. And then for each of the time, the probability that he win. What is the probability to win this game? So we find out already in part A. To get 10 heads, then you can win. And to win, the probability is this, 0.0010. Of course, not this one. This is not accurate enough. You have to use this one. So copy this down, 0.00976563. This is the probability of success, win a game. And he's going to play 7 times. So what is the probability that Logan wins 5 times? We have to find probability of y equals to 5. Okay? So according to the formula, we use 7C5 probability of success. How many times? 5 times. Probability of failure, 1 minus 0.000976563 to the power of 2 times. Okay? And then just calculator. So, next example. So, this one is about Ali. The probability that Ali skips breakfast is 0.4. What is the probability that Ali skips breakfast more than 5 times a week? Could you let the random variable properly? Let x be the number of times Ali skips breakfast. BREAKFAST. Let x be the number of times Ali skips breakfast among how many times? A week, so 7 times. We are looking at 7 morning and observe and check how many times that he does not have breakfast. Let x be the number of times Ali skips breakfast among 7 times, right? So x follows a binomial distribution, as we are going to do it 7 times, n equal to 7, and for each of the times skips breakfast. This is what we defined as success. The probability is 0.4, right? So what is the probability that he skips breakfast more than 5 times in a week? What we are looking for. More than 5 times. That means probability of x more than 5. Could it be equal to 5? No, just more than, so more than 5. That means that you have to find x equal to 6, and also x equal to 7. Add them up. Okay? So from your calculator, you may find 0.0188416. And then after you have to correct your answer in 4dp. So 1, 2, 3, 4. And then your answer is 0.0188. Corrected to 4dp. Okay? And then the story is not finished. Look at the part B. Skipping more than 5 breakfasts in a week is an unhealthy week. What is the probability that Ali has 8 unhealthy weeks among 10 weeks? So now we have to define another random variable. This time, do not use x, use y. Y be the number of unhealthy week. Number of unhealthy week. Among how many weeks? Among, yes, we're going to look at 10 weeks. Then y follows a binomial distribution. We are going to look at 10 weeks. And for each of the week, the probability that it is an unhealthy week, do we know this probability? What does it mean by unhealthy? Skipping more than 5 breakfasts. And we have already found this probability. Skipping more than 5 breakfasts. The probability is 0.0188416. Using this one, not accurate enough. So you have to copy this down, 0.0188416. This is the probability for each of the week being unhealthy week. And you are going to look at 10 different weeks, 10 weeks. So we are looking for what is the probability that Ali has 8 unhealthy weeks among these 10 weeks. We are going to find y equals to 8. Is that right? So that you have to use 10C8, the probability of success in unhealthy week 8 number of times. And then healthy week, this is the probability for having a healthy week, and we need 2 times. Okay? And then use your calculator. So, this story is about James. Look at this. The probability that an egg is rotten is 0.2. Rotten means it becomes bad, expired. The probability that an egg is rotten is 0.2. What is the probability that no any rotten eggs in the box? And we assume that there are 12 eggs in one box. So we are going to check the eggs one by one. And you are going to check 12 times. For each of them, being an rotten egg is 0.2. So you should let x be the number of rotten eggs in a box. Or you should say more clearly, among 12 eggs. More clear. So x follows binomial distribution. You are going to check 12 times. And for each of the time being rotten, the probability is 0.2. This is what we define as success. Okay? Good. What are we looking for? What is the probability that no any rotten eggs in the box? So we have to find the probability of x equal to 0. No any rotten egg. Okay? So you should get 0.068719476 for dp. For dp. And then James is going to buy 10 boxes of eggs because of Some people are now stocking food at home, right? Now James is going to buy 10 boxes of eggs. What is the probability that there are 3 boxes without any rotten eggs? Let Y be the number of boxes without rotten eggs. Amount how many? How many boxes? 10 boxes. Let Y be the number of boxes without any rotten eggs amongst all these 10 boxes. And then Y follows binomial distribution because he's going to check 10 times 10 boxes. And for each of the box without rotten eggs, this probability is not using this one, use this one, 0.068719476. Okay? What is the probability that there are 3 boxes without any rotten eggs? So you have to find probability of Y equals to 3. So 10C3, probability of success, 3 times failure. How many times? 7 times. And then calculator. Okay? Today's video is a bit long because I want to talk about these examples on the book as well. Now please be patient. Let's look at one more, just one more. Because I think I didn't explain this one clearly last time, so please give me one more chance. Now, example 12.6, the probability that a machine produces an unqualified item is 0.2. Suppose each item is produced independently. 3 samples with 5 items each are selected at random. Okay, so we've got 3 samples. 1, 2, 3. All right, this is sample, sample, and sample. And for each of the sample, 3 samples with 5 items each. Each of the sample, there are 5 items. Okay? And we know that for each of this item, being unqualified, the item is 0.2, the probability. So each of them, the probability of unqualified, the probability is 0.2. Okay, for each of the sample, there are 5 items. For each of the item being unqualified, the probability of 0.2 is, right? Okay? So, and then what's next? 3 samples with 5 items each are selected at random from the production line for inspection every day. The quality control team will reject a sample if there are more than 2 unqualified items in it. Oh, this is important. So someone is going to will reject the sample if there are more than 2 unqualified items. Okay. And we have to find the probability that a sample is rejected. Therefore, we are now just looking at one sample. Ignore these. Just look at one sample. This one. If there are more than 2 unqualified items, if there are more than 2. So if there are 3, 4, or 5 unqualified items, then this sample is going to be rejected. Therefore, part A, you should let x be what? Number of unqualified item amount how many items? Amount 5 items, because there are 5 items in one sample. Let X be the number of unqualified items among 5 items in the sample. So X follows binomial distribution, right? We are going to check one by one, totally 5 of them, and then being unqualified. This is what we defined as success, is 0.2. Okay? So we have to find the probability that the sample is rejected. We have to find that X. When do we reject it? When there are more than 2 unqualified. So more than 2 unqualified items, then we reject. So this is the probability of reject a sample. Means when there are more than 2 unqualified items. So that you have to find probability of X equal to 3, X equal to 4, and also X equal to 5. Okay? Okay, so to save time, I just copy the answer. I do not want to use the formula so many times. 0.0579. Okay? And then part B, find the probability that the production line is stopped. Also, when do we stop the production line? The production line will be stopped if 2 or more samples are rejected. 2 or more samples are rejected. How many samples are there? There are 3 samples. So this time, we have to let another random variable, let y be the number of samples being rejected. Number of samples rejected among how many? 3 samples. So y follows a binomial distribution. We are going to look at 3 samples, so check 3 times. For each of the time rejected, what is this probability? For a sample, reject a sample, this probability is already found in part A. You may use this one, 0.0579. Oh, too bad I cannot use the more accurate one because from the book, so it didn't show the previous step, so this is not accurate, not very accurate, just corrected to 4dp. All right, so therefore, I have no choice. I have to use this one, but this is not a very good choice. So, and then next, now what's next? Find the probability that the production line is stopped. When do we stop it? When there are 2 or more samples are rejected. So we need y 2 or more bigger than or equal to 2. Then we stop the production line. This is the probability of stop the production line. Of course, you have to find y equals to 2 and also y equals to 3. And then you using the formula to continue. Okay? So is it more clear now? So today we focus on define the random variable and tell what kind of distribution that it follows, and then answer the question. So today I've prepared you one more exercise also about the binomial distribution. So next time we'll be talking about the geometric distribution, the next one. You may find this new homework on the Google Classroom, so please download from there. All right? I'm sorry for today's bit long video. See you on Friday. Bye-bye.